Hi! In this video we're going to talk about two-dimensional projectiles, which is objects that are flying through the air not just up and down, but also to the side. For our first problem, we got a diver jumping straight out from a 15-meter high cliff at 4 meters per second, and we want to know how far from the bottom of the cliff he lands. Here's a quick sketch of the problem. We've got our diver jumping straight out to the side, which means his velocity in the x direction is 4 meters per second. Immediately, if I draw kind of a simulation of where he ends up going using these circles, immediately his velocity in the y direction starts getting faster and faster and faster, which is what I drew here with these velocity vectors. However, in the x direction, we know that his velocity is going to stay right at 4 meters per second throughout the entire flight. Just like on the last one, we're going to have to break down this complicated motion into two simpler problems. The problem of his motion in the y direction vertically, and the problem of his motion in the x direction horizontally. The way that I'm going to do that is by just making a y-t-x chart, where t is the thing that links x and y. In these problems, time is always the key, because the amount of time that he spends going down is the same as the amount of time that he spends going to the right, so the information doubles up. Now the cool thing is, it's just like the problems we've already worked. The only difference is now there's two of them. There's a problem in the y direction and a problem in the x direction. But how we solve it isn't going to change. We're just going to use our variables of awesomeness. Now, picking at the problem, I'm able to grab three pieces of information just from what we're already told. In the y direction, he didn't jump up or down, he jumped to the side. So his initial velocity in the y was 0. Acceleration is just always going to be -10 in the y direction. Gravity pulls you down 10 meters per second per second. And for delta y, we get -15. Don't let the positive here fool you. The guy ended up going down 15 meters, so you must include a negative over here. And in the x direction, he started with a velocity of 4, and that velocity never changed throughout his entire flight in the x direction. He didn't get faster or slower to the right, so his final velocity is 4 as well. And his acceleration is 0 because this velocity never changed throughout the flight. Now, the thing that we're most interested in on this problem is calculating time, because if we know the amount of time that it took him to hit the ground, if we can calculate t over here, then we can shuttle that answer over to the x part and be able to solve for this problem, because the thing that we're ultimately after is delta x, which is how far he was from the bottom of the cliff when he hit. Now, to calculate time, we're just going to use the old faithful equation, delta y equals 1/2 at squared plus vit. Usually when you're solving for time, that one's going to do the trick. After plugging the values in and just doing a little bit of math, I got that it took the diver 1.73 seconds to hit the water below. Now that we have that information, time, we're able to swing over to the x direction, and we're actually very close to being finished. What we're looking for is how far he traveled. Well, we know that he went 4 meters to the right every second, and we also know that he spent 1.73 seconds in the air. After multiplying the two, I get that the diver landed 6.92 meters away from the bottom of the cliff. Not a bad jump. I'd like to recap the steps really fast just to make sure you're solid on the process, because we're going to be doing a lot of problems that are just like this one. So first, you draw the problem so you can kind of see what's going on. Second, you make your y-t-x chart, and you have your variables of awesomeness both in the y direction and the x direction. Third, you're on a quest to figure out the amount of time that the problem had, because that number is going to link the y part to the x part. It's going to allow you to finish the problem and connect the two problems and make them one. And then finally, you solve for the actual value that the problem's asking for.